Okay. How many people are familiar with recommender systems? I mean, I assume everyone here is, right?
You mean what it does, right? What's like not exactly how to run it.
Yeah, what it does.
Yeah, sure.
Okay, all right. Yeah, so because I know people are familiar with what it does. I mean, I'm not going to spend a lot of time discussing the algorithms or chasing the literature. So what I want to do today is somewhat different. But I mean, before I move on to that, just some preambles, right? So, okay, sorry. Yeah. So basically, the goal of recommender systems, right? Is I mean, it has many goals, but one of the goals is to narrow your options. So these are screenshots of Amazon, a product listing, and then Amazon Prime, which is a video library. So you have all of these. You want to buy, say, an earbud. You want to buy a headphone from Amazon. I mean, you have tons of options. I mean, hundreds, if not thousands. Sorry, my kid is in the room. What do you want?
Your friend is giving me something.
Yes, good to him. I'm on the call.
Your friend is giving me something. My friend is giving Fooberings.
Yeah, sorry about that. Sorry, I'm on the call.
Yeah, you have Fooberings. Hey, I want to play Fooberings.
All right, so
I want to watch Fooberings. Let me watch it. Let me watch it, please.
Sorry, one sec. I need to get you the link.
I mean, what did I move here? No!
Yeah, it's gone up. Sorry about that. So you have bunch of options, right? So how do you get the information you need? Sorry, something in the chat. Okay. So how do you get the right information you need from hundreds of earbuds or from thousands of movies? I mean, how do you narrow down your options, right? So yeah, I mean that's what recommender system does. It narrows the options, to give you the ones that you're most likely to enjoy, the ones you are most likely to interact with, right? So you want to go from this to this, from hundreds of earbuds, you want to go to like a set of 5, 6, and then you can decide what you want, right? So now the question is, how do you go from this to this? So you need some goals. Now, in the recommender system, so please feel free to stop me at any time to ask questions or to tell me to talk slowly because I talk very fast. So you need goals, right? You want to build the recommender system, you want it to perform some certain actions, right? So you have that in terms of goals. And for recommender systems, there are usually two parties, at least the way it is right now. So you have the user. We say, for example, if you're on Amazon shopping, you the shopper, your own user. Now the other user is Amazon itself, Amazon the company. So if you're on Netflix or YouTube, for example, the watcher of the videos, you are the user. Then you also have another user, which is the YouTube the company or Netflix the company. Now, one thing to note is that both of these users have different goals, right? So for Amazon, for example, Amazon, shopping, the shopping websites, they want you to buy stuff, right? So they want to, increase their conversion. They want you to fill your cart with stuff. You want stuff that you don't need, you want you to buy stuff. So that is their own goal, right? Then, but you, the user, you have a different set of goals. So you, for example, you want to be able to find stuff you're looking for, very quickly, right? And then there's this notion of serendipity, so basically, there's something that you really, really like, but you don't even know that you like, right? So recommender systems have this way of sharing, like making you discover very new experience, something that you didn't even know about. So they do that very well. Now that is your own goal, right? And then also the other user, which is the company, also have another goal. They want to increase engagement. They want you to view that stuff. They want you to click. They want you to watch more videos. They want you to browse, spend more time browsing their website, like TikTok does. People spend tons of time on TikTok, either watching skits or creating videos. That is the goal for the company, to keep you engaged, right? So those are a different set of goals, for recommender systems. There are lots more, but I'll just discuss this. So we want to get to this, and then some numbers for how efficient recommender systems really are. So for example, this is I think two of these stats is from a 2013 paper by McKinsey. So for example, 35% of purchases on Amazon, were from recommendations. I mean, that is a lot. So people bought stuff from Amazon, because the system, told them to buy it, and then hopefully those things they bought actually what they wanted to buy, right? Then yeah, so the 75% of views is actually from Netflix. So from Netflix, often people just don't go there looking for what to watch. They open up Netflix, and then the system suggests, okay, you can watch this, you can watch that, then they watch it. So 75% of views from Netflix is driven by the recommender system. Then if you use Spotify, they have this very cool feature, where you discover new music, new release. It's also powered by recommender systems. Then for YouTube, they have about 70% of their watch time is from recommender systems. So recommender systems play a very crucial role in today's technology landscape. Like I said, some of these numbers are from like 2013, so you can imagine what the numbers would be now. Right. So before I delve into the fancy part of recommender systems, I mean the algorithms. I mean, I'm sure you guys probably have come across some of them, but so I won't touch those yet. I want to flip, the way I discuss this class. So I mean, in your head, you probably think that recommender systems are all good, they are great. I mean, of course, they are, right, but then they also have a terrible side. They have a terrible angle to it. There's this notion called filter bubble. That definition is from Wikipedia, so you can take a moment to just read it, so you understand the definition. So when you're done, just let me know you're done reading it. Then I'll carry on. So are you guys done? Hello?
Yeah. To read it, right? Don't read it.
Yeah, you're done reading. Okay, all right. So so a filter bubble, is a natural progression. It's a natural side effect of the recommender system. So I mean, here's a scenario, right? I mean, you go on, say YouTube on say you go on YouTube, you watch one video, right? And then because the system thinks, you like this video, because maybe you watch the video to the end, right? So the algorithm, recommends more of the same stuff to you, right? And then before you know, your entire recommendations are just that one thing, which can be good and it can be bad, right? But then what it does is it's say let's take a case of vaccine, for example. let's say somebody is ambivalent about vaccine. They are sort of not sure, they are skeptical of the vaccine. So they go on YouTube, and then watch a video on vaccine conspiracy theory, right? They watch one video, and then the next thing, because they were engaged, watching that video, YouTube thinks, okay, let me recommend more of this type of stuff, for this user. So then the user keeps watching different videos on vaccine conspiracy theories. I mean, really, the system is in its job. I mean, it's just giving you more of what you like. So that what happens is it creates a filter bubble where the user doesn't get any information contrary to what their current YouTube recommendations give them. So they tend to believe all the information they've gotten from that set of recommendations, right? So this creates a filter bubble for them. So which is why sometimes when they interact with people of different opinion outside of YouTube, it becomes a clash because their own experience, which has been formed, from the recommendations they've gotten on YouTube, it forms a particular side of that story. So that is a filter bubble. Like this particular example is from Fox News, where some people, because they watched a video, some videos on militia tactics. You find out that the algorithm kept on recommending similar things for them, how to stage a siege, how to handle tactical weapons, how to stand against the government. So, and this was from the January 6th hand of the US that happened last year. So recommender systems have real consequences. I mean, of course, you can increase revenue, you can increase watch time, you can do all of these things, but it's important, to remember your building systems, that have real life impact on real people. So this is one filter bubble. Then the second one is your choice of metrics. Engagement. So the filter bubble and the engagement are somewhat related, right? So engagement is good, but not all engagements, for the good of the user or for the good of the society. I mean, like I assume we all know, things, news that are jarring, news that are polarizing, news that are sensitive. I mean, those tend to keep people engaged. Like for example, Twitter, for example, when someone comes to Twitter and then does one hot take, it's very engaging, right? People want to dunk on the person, people want to react. You find people that agree with the opinion, people who oppose the opinion, they all interact. That is engagement, right? So if you are building a recommender system and your goal is to drive engagement, more often than not, the content that drives engagement are usually content that aren't good for this society, like conspiracy theories and fake news. So you have to be very careful, how you pick the metric you want to maximize when it comes to recommender systems. So that's all for this part of the talk. Any questions before we move on?
Okay, yeah. So you talked about the two main challenges that we have, which means number one, it can bring out
I
just part of this.
I didn't get that. There was some noise. I didn't get that.
Okay, can you hear me now?
Yes, I can hear you now.
Okay, yeah. So you made a comment the other time. Two main issues that recommender systems face. Number one, it's segregating people from the or limiting people to specific information based on its assumption of their preferences, and also it could be used. If I want to be sure I got that right before I raise my question. And the second one being the fact that this conspiracy theory principle where you use it to program people's mind by feeding them certain information which might not be the full story.
Yeah.
Good. All right. So let's assume that I have what's it called now? I'm building a recommender system, and let's assume I'm being a religious folk. I want to build people reading Bible or Quran, and I don't want to make them biased about it. I want people to be open to it, but yet I want people to feel, the flow as though they're actually making progress and feel connection with their Bible or Quran or whatever it is. How do I mitigate against such problems as this? Because that would be very bad if I'm programming their mind. That would be a little bit of I don't know what they call it now, but bad from a religious perspective.
Yeah. So you are saying you don't want to recommend to them too much religious information. Is that what you're saying? Or you want them to consider?
What I'm saying is for sales site, it works perfectly fine. Like I need to program your mind and convince you to do things. Okay, but for religious side, I just want people to study. I don't necessarily need them to have a particular mindset because we all just, we learn more the more we read.
Okay.
So let's assume I want to build a recommender system for that kind of thing, but I don't want it to bring in these biases that we already itemized out. How do we?
All right. So okay, good. Yeah, thanks for that. All right. So let me take it from the second one, which is the engagement, right? So I think the thing is you need to first define a healthy metric. You want to build a criminal system, but then you want to design a healthy metric, for that system. So now, in your case now, what would be a healthy metric? So say, for example, you just want people, to watch, lots of videos. I mean, watching lots of videos isn't really a healthy metric, is it, right? So so you scratch that. And I mean, do you want people to share those videos? I mean, that's not necessarily a healthy metric either. So you need to find something healthy. So for your case, I think it comes down to the information people will get from watching those videos. I mean, will they be educated? Will they become better citizens of the society from watching those videos? So I think that's something you and your team and whomever is going to design the recommender system have to figure out. Sorry, Jerry raised his hand.
Yeah, sorry, I just want to understand the question very well. You are building are you building a platform? So you are building a religious platform that recommends stocks from that same platform, or you are writing so is it like a YouTube thing that you are doing, or you have your own platform? Because if you have your own platform for a religious purpose, that means every content on that platform is going to be that religious the contents of religious content. So whatever you are recommending on that system will always be the content on that system. Or I'm not getting the question.
Okay, this is my question, Jerry. I use this Bible app, okay, and I've come to realize that it recommends devotional to me based on previous devotionals I've used. Okay, so say for example, I need to learn about faith one day, and then I'm done with faith. I can't continue to learn about faith. Do you understand? It's important I progress, and a recommender system is going to hold me down because it's going to continue to recommend things that relates to faith to me. What I've learned about faith, probably I want to learn about love, forgiveness, and other concepts. Do you understand?
Yeah.
So how do I build for purchase and sales side, e-commerce side? It works perfectly because I just want to keep programming their mind that, oh, Oraimo is the best. Just keep buying Oraimo products. Oh, when you're done with the herpes, buy the cords and all. But for a religious site, definitely that might not be a very good metrics to work with. So how do I, maximize the recommender system, but don't allow work towards it, giving my people this
Just one content. Okay, I
conspiracy
get
theory effect.
Yeah. So I was building up to that answer, right? So like I was saying, you need to devise a metric that measures how much education someone is getting from that Bible app. So like you said, I mean, if I keep getting the same recommendation or devotion day in day out, I mean, I'm not really getting educated, right? I mean, it is the same thing. So what that means is you need to diversify the recommendations. So there's this term in recommender system, diversity, right? So what it means is not to recommend just the same set of items to a user. You want to make it a little different. So for example, let's say I wanted to buy headphones now, and I go on Amazon, right? And Amazon, maybe based on my previous purchases or whatever reason, it's wants to recommend Apple products, right? That's the classic filter bubble, right? Then when you introduce diversity into your recommendation, it's just sneaking maybe something from Sony or sneaking something from JBL, right? So now you don't have the same set of items. Now you have something different. So in your case, for example, right, when you build a metric that measures how much education that user is getting from your Bible study app, one of those forms would be to introduce diversity. So say today I recommend you, I don't know, 10 devotion, 10 items, maybe 8 were devotionals. Then the system can sneak in, two, say two on forgiveness, sorry, one on forgiveness and one on love. And then the system will watch how the person interacts with this new set of recommendations, right? And then will tune itself. So to cut it short, diversifying your recommendations is a way to make it more healthy. So you have a non-homogeneous set of items the user can interact with. So that's so I think those two actually answer the question. So one, you design a metric that measures how much education the user is getting from the platform. That's one, which solves the engagement problem. Then to solve the filter bubble problem, you diversify your recommendations. You bring in something new. You bring in something at the edge, of the current recommendation. So that's how you solve that problem. Does that answer your question?
Yes, you can proceed.
Okay, so any more questions? Any more questions before we move on? Okay, so I'll take that number of questions. Before I move on, I'd like to just reiterate, so you understand, it clearly. Recommendations are very powerful tools. I mean, I think of all the machine learning, stuff, the products or utilities, I think recommendation systems are very, very powerful. They have the power to, shape opinions. They have the power to drive people to various goals. So I think you need to be very, very careful, when you build them. Yeah. So that's that. So let's review some. Yeah, and these are some references, for the ethical side of recommender systems, which I encourage you folks to take a look at. So that's that. Now let's look at the canonical recommender system. One sec. Can you guys see my screen?
Yeah.
Okay. Can you see the slides on recommender systems? The new slide.
Yes.
Yeah. So okay. So now we'll go to the the algorithm sides of recommender system. So yeah. Okay. So how do we build recommender systems? Does anyone know what like the basic form of a recommender system is? Like, I mean, like, what's the most basic or the basic recommender system that you can build? What do you think it is? Anyone?
Think anything that is based
Sorry,
on, yeah, I think anything that is based on user information, or like you can just easily classify that, okay, this particular person, based on the information he provides of himself, you can build a recommender system for the person. Say something like, I'm trying to think, okay, say someone that lives on an island or something, you can just recommend, maybe like you can build a recommender system of, okay, prices of ferries, or like something that aligns with the person, that might align with the person's interest based on the information we provide. You can't suggest something for a kid, for an adult, so something like that. You just have to like, that's like probably like the first thing you can use to um, um, start as a foundation. So some like as a basis, you can just like start based on their user information. That I guess.
okay. Okay, so what happens when you don't have the user information? What do you do then?
Probably random. I don't know.
Yeah, I mean, you're right that so when you do have user information, yes, you use user information, right? So I mean, I think some websites, when you sign up, they ask you for your interest. So they ask you to choose. Sorry, Ibrahim, please go ahead.
Oh, no, I wanted to say something, but we're already past that. I wanted to
Okay.
suggest that as regards the question you said, what happens if we do not have the user information? It's not possible to recommend the like between the products themselves, like the similarities between the product, irrespective of the user.
Yeah. So how do you know which products?
To start with,
What?
you say, how do you know which product to start with?
Yeah.
Well,
Providing that probably that's the
Everybody
first
coming to a site, coming to search a product. If I go
hey,
to
Joseph.
so you
Jumia,
start
I'm
from
not
that.
just going to Jumia because I want to go to Jumia, right?
imagine.
And even if I have an information of someone purchasing or an information about their purchase and the rating they gave that product, then I can look at, okay, if another user bought this product and gave it this rating, and this person comes in and gives it a similar rating, that means their preference might be aligned, which is a very big assumption, but at least something to start
Yeah,
building
but
on.
the issue now is that you do not have the user.
So thing is, you are jumping ahead. You assume, you have user information. You assume you have item rating. Joseph is using his hand or their hand. Joseph.
Okay, mine is not a comment on this. Is another example I wanted to give.
Okay, go ahead, please.
Okay, like a crop recommender system, like
Okay.
based on the different type of soil, you can recommend the type of crop that can be grown on those soil.
Okay, yeah. So you're still assuming there's some information. We are. You assume there's some information. So I think for crop, I think that's a little too niche. There's no way you want to to plant. You want to know the type of soil to plant. That's different. So let's say a Netflix example now, or Amazon. You don't have the user information, right? You don't have any item rating. You don't have the user's item preference. You have no information about the user. You have no information about ratings or likes or comments or sentiments. How do you build a recommender system for that user?
I'll force the user to register.
I think for that.
So if you register, at least from your, I can get from.
Okay.
For that, most time they can use based on brand knowledge, like based on the location.
Yeah, what if you don't have the information about the location? What if the user decides not to share their location with you? All right, so I'm going to end this so we can move on. I think there's a very easy way to solve this problem, right? So let's say you're on Amazon. Somebody comes to your website. They are not registered. They've shown no preference. They've done nothing. And actually, you find this problem with hotel bookings. When people want to book hotel, often they aren't a signing visa. They have no visa information, right? So what people often do is they just use popularity. So basically, what that means is, they go through their systems. They rank all the items. Say Amazon, for example, it ranks all the items based on popularity. How many people bought this item, in the past 7 days, for example. So say the ranking is, most people buy AirPods, right? It makes sense to recommend AirPods to that new user because most people buy AirPod. Now that's a recommendation. It is not personalized yet because you have no information about the user, right? So that's what people often do as a very first step. So if you have no information about the user, you have no information about their preferences or whatever, you can recommend popular items. Say then you can scale it by a window, for example. Say maybe you recommend the 10 popular items in the past 24 hours, 24 hours, for example. Yeah, so that's one way to get this going. Now, this problem where you have no information, about a user is called cold starts. So, if you have no information about the user, or even if you have no information about the item, it's called a cold start problem. Right. So now let's move on to the information, the data we can use to make to build a recommender system. I think like a lot of you already alluded to, obviously you need user information, right? Now, I mean, there's no blanket, this is the information that you must have to make recognized system. I think it depends, on the kind of recognized system you're building, For example, so we have 3 examples now. We have the crop recognized system. I mean, there's no user information in the crop recognized system. Nobody cares about your age. If you are building a crop recognized system, they don't care about your Netflix history, right? So the information we use to build a recognized system depends, on that particular niche, on that particular application. So if you're building a Bible recognized system, I mean, you probably don't need to worry about soil texture, right? So let's say, so let's pick an example and walk through it together. So you notice for this talk, I'm not going to put too much weight on the specifics of the algorithms, because I think a lot of you are competent enough to pick up on the algorithms and walk through it. So I'm going to spend a lot of time around the soft, I'll say the soft skills side of recommender systems, ethics. Are you building the right thing? When you build it, how do you ensure that it's serving your users very well? So let's pick an example now. If you wanted to build a recommender system for Netflix, which information will you need?
Okay, you need like the user's information, like the person's biodata and like the person's location also, and like the personal information about the person. And you also need information about the movies, and perhaps the length of the movie, if there's a rating already for the movie, fine. The artist, the director of the movie sometimes might determine how good the movie might be. So like you need both information to build a recommender system for Netflix. Right?
Yeah. I mean,
Okay. If I can talk,
yeah, please go ahead.
I would say first, there's some ready available information that I have from my site that is not from the user. It's just from the item.
Okay.
I have the name of the movie. I have the genre of the movie. I have probably some previous rating of the movie.
Okay.
That is available on my site. Now, there's one reason Netflix makes people register on their site, and that's because they want to get user info. So they want to know an ID, which is name or ID of the user. And they want to be able to tie some information to it, like what's your favorite genre of movie, what's your age, so they can know what kind of movies to recommend to you, and many other informations like that. So for me to be able to build a recommendation system, it depends on what kind of recommendation system I want to build. If I want to build based on content, based on item content, then I can just stick to the information on the page and just say, if someone searches for this movie, then these are possible movies they probably will look for. I can build it based on user preference. There's information about the genre. If someone wants something in action, just give them this kind of movie. I can just combine the two.
Okay, that's fair. Yeah, I think that's enough information. All right. So I mean, this is an interesting question. Have you folks done anything on unsupervised learning?
Yeah.
Oh, you have. Okay. All right. Can Do you have any idea how you could build the recommender system using, say, clustering, for example?
So you clustering, that means you're looking at people's preference. So
Okay.
Yeah, and okay, so does this preference align with some other users on the system preference, and then you put them in the same cluster and all of that? Is that what you mean?
Yeah, that makes sense. Thanks. Yeah. So this is just some challenges. I mean, I think we've touched on the, some of these lack of usability, lack of data, which is called cold start, right? I think the other thing I wanted to discuss on this slide is privacy. So there was this very funny incident that happened, when I was one time, when I was building the computer system. I mean, it's funny, yes, but then, I mean, you can imagine the severity, of that gaff if it had been something much more serious, right? Okay, so I was building the computer system before and a big commerce store, right? And so I built it, deployed it to production, right? And the recommender system, I mean, it performed well on paper, right? I mean, it had, very nice metric start and it had a decent score. But then we found a very odd behavior. So for one user who is a guy, like, I mean, a guy, he was recommending an item that was nowhere near what the user had interacted with. There was nowhere near, the purchases, the purchase history, or the views or clicks of that user, right? And it was funny because it was recommending an item of clothing for a female for this particular user, which was odd. So I mean, myself and one of my colleagues were joking that it's very funny if that user's girlfriend saw his recommendations and saw that he was buying female clothing that he didn't buy for her. I mean, it was just something funny that happened one time when I built a communal system. So it's like, oh yeah. There's yeah, it makes sense. Yeah. So there is there's, like you said, affinity. So there's a way to group items. So there's this popular stuff on Amazon. So people that bought this also bought that. So for example, I mean, say when you go to a store and then buy diapers. I mean, more often than not, you want to buy baby food, right? Like the example here that says, when say you buy, guy, I mean, you probably want to buy sugar and granuts, yeah. So that's something to consider when building the computer systems. Sorry, it doesn't work. So this is just some background on. Are you guys familiar with the Netflix price?
Yes.
Oh yeah. Okay. Have you gone through the algorithm for the Netflix price?
I just know they want, like, I think it's 1 million naira or so. I say naira, dollars, for who can build like a better recommendation, something.
Yeah. So I mean, they had this very huge stuff back in the day, to build the recommender system that was going to, beat, their own system. And then there was the price of $1 million. And yeah, I mean, people went and built it, and then they beat Netflix 6 in-house recommender system. But then they couldn't deploy the model because it was a lot of work, And I think this is something you would find, in machine learning in general. Like, people have all these, fancy models, right? But it becomes very difficult to take that model to production because it's just not worth the engineering efforts, to keep it in production or take it to production. So that's something to consider. So don't feel bad when you read like in the industry you find people still using things as basic as linear regression, stick regression, or even matrix factorization, random forest. That's because the engineering required to do all these fancy models. Sometimes it's not just worth it because there isn't a huge performance gain over those classical methods. All right, so collaborative. So I mean, there are two main camps, right, in recommender systems. So you have the content-based recommender systems, right, and then the other one is sort of collaborative filtering. So what content-based means is you recommend stuff to people. You build a recommender system, using the content of the content description of the user or of the item, for example. So say wanted to build the content-based recommender system for Netflix, right? Now you would need the user information, like you folks rightly pointed out. Now you won't care you won't care about ratings or likes or or those those kind of information. You only care about the content. So say for example a user in their profile said they like watching action movies, right? So all you need to do is just take that information and then go to your catalog and then pull out all the movies in that action genre. So that's like that really content-based recommendation. I mean, it's as simple as that. Now, the other side of, I mean, of course, there are much more complex things that goes in there. But then the other one, which is more popular, which is widely used, is collaborative filtering. Sorry, it's like yeah. So the other one is collaborative filtering. So what that really means is you aggregate information of all your users. You aggregate information of all the items, the ratings, the likes, the whatnot, and then you use that information to make recommendations for your users, for your items. So you use all the same information you would use for say content based recommendation, the user preferences, the user rating for a movie, the item information too. So you use that to build your collaborative featuring recommender system. So for this kind of recommender system, there's a canonical giant matrix, which is this matrix that is shown here. So and what I make typically say you wanted to build a user item recommender system based on ratings alone, just based on ratings alone, right? So these rules will be your user record. So for each of these in your system, you'll have one row, like 1, 2, 3, 4, four rows for the user. Then for the items in the system, you also have columns. So I mean, this can be Casino Royale, this can be one Hollywood movie. So you have that information, right? And then these numbers are the ratings that the user in your system give that particular movie. Now, here's where things start to get funny. So because there are lots of movies, right? There are tons of movies, right? And then there are also maybe tons of users. It's not possible, that everyone will have seen all the movies, right? I mean, it's not possible that one user rather will have seen all the movies, right? But it's possible that when you aggregate all the information, most users will have seen all the movies. So now the task becomes for users who haven't seen a movie, how do you guess which rating they will give that particular movie? So let's say this is user 3 here, right? How can we tell what user 3 will give this movie, in this column, right? So it becomes collaborative because we use the information of other users and of other items to fill this matrix. Is that clear? Any question? Please ask me questions, or I'll leave people like experts, and then my work is done.
Sorry, can you go over the matrix again?
Right. So it's like, okay, yeah. So this is a better one, right? So you have this matrix here, right? So you have rows. The rows are the users, right? And then the columns are the movies. And then those numbers recommend the score, or the rating that that specific user has given to a particular movie, right? Now you notice that there are some empty cells here that have no numbers. This is empty, this is empty, this is empty, 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 and empty, right? So I mean, how do we fill in those slots? Yeah, you can see. So this is empty. I mean, we don't have a score for this user for this movie. No score here, no score here. So I mean, how do we fill in these numbers? Because I mean, the idea is, if you can fill in these numbers, then we have a way of knowing if that user would like that movie. So the score is here from 1 to 5, with 1 being that the user did not enjoy that movie, and 5 being that the user really likes that movie, right? So we want to fill in these question marks, because if you can fill in these question marks, then we can say, okay, listening, does it make sense?
Since you
All
remember the
movies
question,
that no one has no.
Sorry, I didn't get that.
Jerry, you should go now.
Sorry, say again.
Okay, I have a question. I thought Jerry wanted to say something. Since we are now having multiple variables to fill in the gap, and like
Okay.
in the second row now that I have 2 and 5, I even like
Yeah.
say the mean value of
Sorry, say
the
again.
row.
Sorry, say again. Say again. Hello?
Like the second row that has 2 and 5, and
Yeah.
and in the first column, it's empty, and the last column is empty.
Yeah.
So I want
Yeah.
to say, like, you get the mean value of the ratings that the users have given, or you will just do like the maximum value of the ratings that
No, no,
like any of the users get.
no. So it does something little more intelligent than that. So I mean, so if I understand what you're saying that you just do an average of these 2 and 5, right? And then if you have 3.5 here and 3.5 here, no, it's not going to do that, because see, so this 1 and 4, right, on this column, sorry, okay, yeah, so the column is the item, and the rows are the users, right? So I mean, it will just use this 2 and 5, because the empty cells are different items. They are completely different items. So these 2 and 5, the items, they probably have no relationship to the items in the first column and the last column. So we have to use all the information. We have to use all the all the information, in that matrix to fill in those numbers. So, for example, right, this user number, the user in row 2, as they have filled in 2 and 5 right now. The idea is to find another user, right, that has given a rating to the movies in those middle columns, which, for example, is this user here that has 3 in the second column and 5 in the last column, right? So we want to use, how their own rating compares, to this user, and then this user, in the last row that has filled 4 for that third movie. So we need to use that entire matrix, and infer how the ratings of each user differs regarding the each item. So we use all that information to fill the matrix. We won't just take the average of the user for that row. No, we won't do that. Yeah, so we use the entire matrix, and so it does that in a process called matrix factorization. Sometimes they call it matrix decomposition. So that is the approach. Does that answer your question?
Yes, yes, it does. I have another question.
Go on, please.
So, do we have something like outliers recommendations as regards this kind of data? In the sense,
Sorry,
like, we have.
Do
we have something like an outlier recommendation for like this type of data? Sometimes
I didn't get what you said. Outlier recommendation.
Like okay, now there are some people that are a bit naive, that they are very, very less interested in like a lot of things. So like you just recommending one. And if you're now trying to include them into the recommendation system, knowing the fact that okay, this movie is really interesting, but this guy is very difficult to impress. Like if there's no way you're going to get something good out of it. So like that's like an outlier recommendation. Or someone that is always recommending 5, any small thing, the guy laughs, and anything that's not funny, it laughs, and before you know, it's now giving me. So how did you deal with that?
Yeah, yes, where the beauty of your have you guys done any class on data exploration, EDA, exploratory data analysis?
Yes,
have you guys done it?
yeah.
No, you haven't.
We have.
Okay, right. So typically, you won't just get data and then chug it through a machine learning model. You will go through an EDA process, right? You will look for outliers. You will look for bad data. You will look for funny things happening in data, right? So you would have done that and I identify those very funny instances, and either you exclude them, from the data you build your model on, or you look for some very interesting approaches to handle that problem. But so now the good thing now is, right, I think at least in my own experience, the people who are difficult, right, are only a very, very small percentage of the entire user base. So it's not something you typically worry about, because that signal they are giving will be drowned out by the other accurate information from your from the other users. That's something to keep in mind. Now, these are some approaches to collaborative filtering, and it was something I alluded to earlier in the previous slide, right? So we have the user-to-user approaches, right? We want to find the user most similar to me. So say for example, we have let's say three movies, right? We have 3 movies, A, B, C, and I've watched A, but I've not watched B and C, right? So now the user to user approach, what it will do, it will find somebody else who has who has watched A also, right? And maybe they've watched B and C. So say I gave that movie A 5, right? Because I really liked it. But then I've not watched B and C. And another user has watched movie A and B, and they gave their movie A 4, right? Now, because our rating, are somewhat similar, for me it's a 5, for them it's a 4, and then they've watched movie B, and they gave movie B a 5, right? The system would think, okay, because we have a similar rating, it might make sense for me to also watch movie B, right? So that's a user to user approach. So in this case, for example, right, if you can find out that row, the user that has 2 and 5, can you folks see that row?
Yes.
Yeah. So second row. The user has 2 and 5. For the second and third movie, right? Now, if you find another user that is similar like them, which user would that be?
Fourth guy.
Say again.
The fourth guy.
Yes. So I mean, and that's because for the third movie, the user number 2 has 5 and the user number 4 has 4, right? So now it makes sense for the recommender system to recommend movie number 1 to that user, right? Because they have something in common. And then I mean you could also say user number 3 is also somewhat similar, because user number 3 has like an average rating for movie number 2. Meanwhile, user number 2 said they didn't like it. So maybe you could suggest movie number 4 to them. I mean, so the thing is, with recommender systems, I mean, you will get some funny recommendations. I mean, I don't think it's possible to be perfect, right? I mean, I don't think it's possible to be perfect, but it's possible to do very, very, very good with recommender systems. So that's something to keep in mind. Now, the other one is the item to item approach. So that's just the inverse, like it's just the inverse of the user to user approach. I mean, so I'm not going to go through that. And then we have matrix factorization. So what this does is, I mean, it's not user to user, it's not item to item. It takes all that information. It takes this giant matrix, and basically what it does is fill in the gaps using all the information from the matrix. So that's in a nutshell what it does, and it does it through something called low rank decomposition. And how that works is it basically finds some other matrix such that when you do a product of that smaller matrix, you would find this giant matrix as the result. So that is what it does in a nutshell. So yeah, this is your matrix factorization. Yeah, no, sorry, this is your user to user item. Yeah, this is just some notation for the user to user approach. Have you guys come across similarity measures?
Yes, I've seen something like that, like cosine similarity and the rest.
Yeah. So I mean, I think so. For example, what in this case, right? In this case, what would be the simplest similarity measure you can come up with? So in our case here, what's the simplest similarity measure you can come up with?
Like the simplest similarity measure, you can see row 2 and 3. are like the closest ones.
So yeah,
think.
so how do you define closest?
Oh, well, I'm just like summing them up together and like 7 and 8.
Yeah, someone is not going to work very well. I mean, someone is like no. I think I mean, yeah. I mean, I've seen people use Summit. In fact, people used to use Summit, but then they figured out that oh no, this is not a good idea to use Summit. Yeah, so someone isn't a good is not a good but I mean it's a start. Yes, like I mean it's it is a start, right?
Yeah, it is a start.
Yeah, so something you can do is to take the squared of the differences, right? You it's basically your roots mean squared error. So I mean if you take the square of the differences, I mean that is something that could work. I mean that's not something that actually works. So I mean it's very easy, right? So for for those cells where they have values in common, right? You can just do say a subtraction, right? So between this one has a 5, that one has a 4. So we subtract it. It's either 1 minus 1. If you take the square, that's 1, right? This one has a 2, that one has nothing. So let's assume that's a minus 2, right? So you take the squared, that's 4, right? So you can define a similarity measure and say that okay, when I take the root mean squared error of any two user of any two user rows, if that value is not more than 10, right? Then I can recommend an item from user 4 to user 2. I mean that's similarity. I mean it's as simple as that, right? So I mean it's just a way to measure closeness. That's what similarity is. Yeah, but of course if you have more sophisticated ones, I mean in a way this is what this does. Yeah, so we have the cosine similarity. And like we said, you treat your missing values as 0. So like that's what it is. So when you define your similarity, I mean you will have this threshold and say, okay, once the similarity is below this value, I don't want to associate this user to that user because they are very dissimilar. And then the person correlation, I think it has a 1 if the users are similar, and I think a -1 if they are dissimilar. I think that's what it does. Any questions? Any questions so far? Do you have questions?
All right, I think we should move on, although the formulas are very strange.
They are very strange. If you say the formulas are very strange, then I wonder what you've been learning. How they are very strange, really.
Like
Okay,
the notation.
oh, you're not familiar with the notation.
To an extent. I
Okay.
don't know about this.
Okay, so all right. Do you know what this E means?
Summation, of course.
Yeah. So I mean, that's what you need. So the big E is summation, right? And then the big X, that your giant matrix, and then the I and J are basically your row and then your column. That's what that is.
Mm-hmm.
Yeah, and then you do that for the entire matrix. I mean, that's all. That's all that is.
Okay.
Yeah, like this someone said, x bar is the mean, your average, if you will. What's next? Yeah, so matrix factorization. Like I said earlier, the idea, right, is to fill in that, giant matrix. We have results, we have items, and then we have the ratings for some. We have ratings of some users on items, right? But then for the most part, that matrix is going to be very empty because like I said, most people wouldn't have seen all the movies, right? So it's going to be very empty. I think in my experience, I've seen sparsity, which just means the percentage of empty cells in a matrix. I've seen up to 99.9% sparsity, right? So say for a matrix that is, I don't know, let's say 100 by 100 by 100. So that probably means maybe you have around just, I don't know, 20 cells filled, right? And now that is also a problem. You can't do decent matrix factorization if you have very huge sparsity, because I mean the algorithm doesn't have a lot to go on, which means the predictions will be a little, if not just random. I mean, so if you look at it from a math perspective, the the algorithm has a problem to solve, right? It will find a solution to the problem, but the issue is if you don't have any data, that solution won't be useful to you, right? So you want to make sure that you don't have too much sparsity in that matrix. So I mean, which is why it's always good to ask for feedback. When you use Netflix, it asks it prods you for a rating, thumbs up, thumbs down, because it needs to know, because the more information it gets about your preference, the better it gets at giving you accurate recommendations. Yeah. So, like I said, this is your for the matrix factorization. The idea is to find, two smaller matrices. So you have the user matrix, right? And then the item matrix, which is this U here, the U and then the V. So that's your user and then your item matrix. So if you can find these two matrices, then we can solve this matrix factorization problem, because we'll have been able to fill up all the empty cells, right? And now we have a loss function, which is a squared error, which is similar to what we went through when we did that user example, right? And then we have a loss function which we want to minimize. Do you understand the notation for the loss function?
Yes.
For yes.
Yeah. Okay. Good. So, any questions on this matrix factorization? Do you want to know any specifics? I mean, so this I think it pays to really know matrix factorization very well, because I mean it's a simple but very powerful tool. I mean, of course, I mean there are tons of very fancy models, but then like I said earlier, I mean often it's difficult to get these models in production. But then for matrix factorization, it is battle tested. It is tried and trusted. Like people have been deploying matrix factorization, like since forever. So I mean, even if you have to build the European system, it's often the case that you will start with a matrix factorization model. So if you have any questions, please ask, so I can, we can treat these subjects very well. No? Okay. We are going to move on there. Yeah, I'm not going to go over these. So I think this is yeah, so we've come to the end actually. So any questions?
Well, how do I know if I went Python?
Oh, sorry, there's lots of noise. I didn't get that. Sorry, second. So I didn't get that. What did you say?
Can I? So this one now, do I? Is it on SKLN? How do I use it on the system? Or whatever?
How many of you want to do a lab? How many people are interested in doing a lab on a computer system? So I have one hand raised. So I think if you have enough interest, we can go through a lab. I mean, we can organize a session. Go through a lab. We have data. We have our Jupyter notebooks, and then we go through a lab, and then we walk through this process, end to end. So I mean, if there's interest, I think you folks should speak with Teju. So you speak with Teju, and then she'll get to me, and then we'll organize something. So there's interest for it for a lab. Then this is something that we can do together. So